There are a lot of unusual things going on in our solar system right now. Of course, we have the interstellar object 3I Atlas, which sometimes looks like a comet, but it also has a bunch of other unusual features. It's heading towards Jupiter. We see it has a tail that's clearly pointing towards the sun, which is pretty weird. It's also spewing out plasma, gas, dust, and a lot of other things. And we really don't know what this object is. It could even be a plasma entity. Stay tuned, because what happens next will blow your mind. If you are fascinated by the mystery of Atlas 3I and want to see more amazing space stories, hit that like button and let the universe know you are watching. Every click helps continue the search for the unknown. Comment below and let me know where you are watching. I would love to know where in the world I am witnessing this. 2 comets with opposite tails have just appeared in the solar system, forcing scientists to reconsider what they thought was certain about how comets interact with the Sunday. 3I Atlas, which once shocked the astronomy world because of its strange tail pointing straight towards the sun against all familiar laws, is no longer a unique case. Comet C 2025 R2 Swan has just joined the abnormal club with a completely opposite tail, forcing observers to ask, what is really going on in the space near the sun? According to classical physics, comet tails are always blown away by electromagnetic radiation and solar wind, so they should point back towards the Sunday. However, in just the past week or two, both 3I Atlas and R2 Swan have simultaneously emitted streams of plasma, dust, and gas that seem to be pulled back toward the center of the solar system. This tail structure is so rare that it is virtually unprecedented in observational history, implying the involvement of extremely complex plasma interactions, local disturbances in the solar wind, or even a form of magnetic field variation that current models cannot describe. In a context where plasma and heliophysics are still full of unknowns, these 2 reverse tails are becoming a living natural laboratory for new theories. What makes this phenomenon even harder to ignore is the striking similarity between the 2 comets. Both 3I Atlas and R2 Swan orbit near the ecliptic, which puts them in the zone most affected by solar activity and interplanetary plasma flow. They both emit a characteristic green hue, the emission color of excited carbon molecules that is almost identical. They also passed perihelion at extremely close intervals, R2 Swan on September 12 and 3I Atlas on October 29. Most importantly, their unusual anti-solar tails formed almost simultaneously, as if some common, invisible factor was driving both systems. Some astronomers and space physicists have suggested that the phenomenon may reflect growing instability in the plasma environment surrounding the sun, especially during the active phase of the stellar cycle. There may have been a local reversal in the solar wind or a magnetic disturbance strong enough to bend or even reverse the direction of the comet's jets of material. In more daring hypotheses, one cannot rule out the possibility of an unexpected element, an invisible space disturbance, a stream of strange particles, or a completely new interaction mechanism between the comet and the sun's magnetosphere not recorded in previous studies. The near-perfect coincidence of orbits, colors, perihelion timing, and especially the tails pointing toward the sun of both comets has created a fascinating scientific mystery. If this is more than just a series of coincidences, we may be looking at an important clue to a new physical mechanism that could rewrite our current understanding of the relationship between comets and the sun in the solar system. In that scenario, 3I, Atlas, and R2 Swan would become the first model objects for a completely new chapter in modern astronomy. But the story doesn't end there. Equally haunting is the location of the 2 comets on the cosmic map. They are located almost on opposite sides of the Earth, forming what looks like a giant pincer movement around our planet. No one dares to say this is a deliberate tactic, but in the context of information about extraterrestrial technology, new revelation programs, and a surge of interest in anomalous phenomena in the solar system, it's not far-fetched to wonder if there's a larger cosmic strategy. This contemplation becomes all the more worthwhile as the space environment around Earth becomes increasingly dense with inexplicable events, from mysterious signals, strange plasma structures, to a series of objects possessing properties that seem to completely defy the normal laws of physics. The solar system seems to be entering a new period of chaos where human intervention is almost zero. In that picture, the two comets with opposite tails moving symmetrically around Earth and exhibiting unusual phenomena simultaneously create a composition that makes many people wonder, is this just a coincidence or a sign of something larger? A cosmic operating model that we have yet to touch. We are not claiming that there is a mastermind behind all of this, but what is happening clearly suggests that the solar system is not as quiet as the classical models once described. Perhaps this is a reminder that humanity is not entirely alone in the cosmic energy picture, and that there are deeper strategies, energy flows, or cosmic forces that we are only seeing the tip of the iceberg. As strange phenomena appear more and more frequently, it is not only interesting, but also urgent to broaden our thinking to see the whole picture, because the universe seems to be constantly sending signals that perhaps it is time to take them more seriously. To understand this pincer movement, we need to go back to when R2 Swan entered perihelion on September 12. Orbital simulations show that it was only 0.5 AU from the Sun and was only detected just as it was approaching the inner solar system. This means that almost the entire journey into the solar system took place outside our effective observation range, exposing the fact that humanity's ability to monitor space remains limited despite the continued expansion of the telescope network. In retrospect, simulations show that 3I Atlas was still in the asteroid belt, while R2 Swan passed very close to Earth before 3I Atlas reached perihelion on October 29. So far, the models show that 3I Atlas, Earth, and R2 Swan are almost in line, creating a striking symmetry. Both comets have developed tails that point toward the Sun, an extremely rare phenomenon, raising the question of a common factor driving both. Looking more closely, astronomers realize that R2 Swan also moved very close to the ecliptic plane, almost identical to 3I Atlas. Orbits near this plane are often strongly influenced by solar activity and interplanetary plasma flow, causing small disturbances in this environment to magnify into large effects. The similarities between the two comets, from their positions, orbits, physical characteristics, to unusual manifestations in their tails, are therefore difficult to dismiss as a mere coincidence. And it is this unacceptable point that is forcing science to expand its theoretical framework to explain what is happening right in our cosmic backyard. From the strategic perspective of the entire solar system, the simultaneous appearance of two large, unusual objects on opposite sides of the Earth creates the feeling that the space around us is locked in an invisible battle. In the deep space environment, especially near the Sun, where solar, wind, radiation, and magnetic fields are always at extreme levels, any change in direction of motion requires a huge amount of energy, far beyond what conventional gravity can explain. Yet, sporadic reports over the years of objects that can suddenly accelerate or change direction in an unusual way continue to appear, leading to a series of hypotheses about unknown technologies or completely new physical mechanisms beyond the current framework of understanding. When you put all the factors together, from the near ecliptic orbit, the remarkable alignment, the close perihelion, to the presence of a tail pointing toward the sun. The picture that emerges goes far beyond the realm of ordinary comets. It raises a fundamental question. Is there some kind of as yet unidentified interaction in near-Earth space where dust, comet, plasma, and the sun's magnetic field interact in ways that current models don't capture? In theory, it could all be a rare coincidence. But when you consider the possibility of technologies beyond our understanding, which have been suggested in reports of anti-gravity phenomena and unconventional propulsion systems, the story seems much deeper and more complex than the classical comet models suggest. For verification, it is not enough to rely on speculation. One of the fastest and most reliable channels for information for the global astronomy community today is the astronomer's telegram, where researchers urgently announce new phenomena, from fragmented, mutated comets to gamma-ray bursts at distant cosmic distances. In the case of R2 Swan, the astronomer's telegram posted a particularly remarkable telegram with details that surprised even seasoned observers. The announcement read, "Comet C 2025 R2 Swan has a reverse tail. The long-period Comet C 2025 R2 Swan has been the subject of 2 telegrams from astronomers. Recently, its brightness has increased significantly, accompanied by signs of fragmentation. Sudden increases in brightness are often associated with flares of activity within cometary nuclei when ice and volatiles are heated, releasing large amounts of gas and dust. However, the accompanying fragmentation suggests that R2 Swan is undergoing a more severe phase of instability than is typically expected. More significantly, the report also notes that K1 Atlas, another comet often confused with 3I Atlas, has also broken into 4 pieces. This series of successive fragmentation events suggests that something is happening simultaneously in the cometary system near the sun. Not just random breakups, then dollars. The report goes on to describe that R2 Swan's orbit has a period of about 784 years, meaning that each time it returns to the neighborhood of the inner solar system, it encounters a completely different state of solar activity over the course of millennia. Importantly, the geometry between the Earth, the comet, and the sun is highlighted as a key factor in determining how we see the dust and plasma structures in the comet's tail. The report notes that the tail only reveals particular structures at certain elongation angles when the Earth crosses or approaches the comet's orbital plane. At these angles, larger dust grains, which are less affected by radiation pressure, can stick out as a structure that appears to point toward the sunday. In other words, the phenomenon of comet tails appearing to point towards the sun can theoretically be explained by geometric factors and the properties of each type of dust particle in the plasma environment. However, that is also the point that makes the story more worth pondering. Because if based only on geometric models and dust distribution, reverse tails are already an extremely rare phenomenon. In the current case, both R2 Swan and 3I Atlas simultaneously show reverse tails, are both green, show signs of instability, move close to the ecliptic plane, and are arranged in a symmetrical order around the Earth. At this point, we can no longer consider everything as purely a story of perspective and irradiance. So the question becomes clearer: how did the sun-facing tails of these 2 comets actually form? Why did they exhibit this rare structure at about the same time? Is this a sign of a new physical process? Some previously undocumented interaction between solar plasma and comet dust? Or is it a manifestation of something beyond the usual physical framework we use to describe the solar system? I'll leave the research link in the description, but more importantly, when these rare phenomena occur simultaneously on 2 different comets in 2 symmetrical positions, we have every reason to ask questions about what's going on in the space around Earth. A question that up to this point, even astronomers have not been able to give a definitive answer. Based on the measurements and observations that have been collected, the picture of R2 Swan over the past period has become clearer in a way that is both scientifically rigorous and thought-provoking. In early November, there was no sign of R2 Swan possessing a clear tail pointing towards the Sunday, but just a few weeks later, the phenomenon suddenly appeared and became more prominent. Part of the reason may be that the geometry between Earth and R2 Swan's orbit has gradually improved, allowing us to look directly at structures that were previously hidden. However, this possibility does not rule out a more interesting hypothesis, that the tail pointing towards the sun is itself a structure that has only recently formed, and that the unusual synchronization between R2 Swan and 3I Atlas is something worth seriously questioning. On November 10, images showed R2 Swan as a tiny faint streak of light pointing toward the sun, while the main tail continued to extend away from the sun like a standard comet. But by November 18, the transformation was almost unbelievable. The tail pointing toward the sun had ballooned, lengthened, and become more distinct than any previous image. From here, two distinct structures were revealed. One, traditional tail being blown away by the solar wind, and a second tail growing in the exact opposite direction, heading straight toward the center of the solar system. The more we look at R2 Swan, the more it resembles 3I Atlas in an almost haunting way. Not only are they green, not only are they orbiting close to the ecliptic, but they now both have rare tails pointing toward the sun, and they appeared at roughly the same time. If we zoom out to the entire solar system, their current positions are even more striking. Both are on opposite sides of Earth, forming a near-perfect symmetry, a slow but persistent pincer motion around our planet. From a purely scientific perspective, all of this remains may be framed by rare geometric phenomena and complex plasma dynamics. However, when you look at the entire sequence of events, the coincidence of timing, physical characteristics, orbit, color, tail structure, and symmetry around the Earth, it is hard to dismiss this story as a mere statistical accident. We may be witnessing an astronomical event that has never been recorded, or it may be just the tip of a much larger process taking place in the space around the Earth that we are only beginning to recognize. Whatever the final answer, the increasingly obvious similarities between R2 Swan and 3I Atlas push this story far beyond the realm of a simple comet phenomenon. When placed in their current pincer position, the cosmic picture becomes not only strange, but also gives the impression that there is something, a system, a mechanism, even an observer, silently watching the Earth from opposite sides of the sky. In recent optical observations of R2 Swan, we have noticed that it increasingly resembles 3I Atlas in its apparent size, tail shape, jet structure, and cometary nucleus ejection pattern. Descriptions and reports from the astronomical community indicate that R2 Swan not only has a main tail extending away from the sun, but also a distinct, stable jet pointing in the opposite direction, towards the sun, consistent with the characteristics previously observed for 3I Atlas. More remarkably, these descriptions do not come from a single source. Multiple independent observational groups, from professional observatories to amateur astronomers around the world, have recorded the same phenomenon. On community platforms like X, new images and reports are constantly appearing, reflecting a broad consensus that R2 Swan's sun-facing tail is completely real and not an optical illusion, measurement error, or data noise. The systematic repetition from multiple observing sites with different instruments shows that the structure is stable, organized, and has a clear physical basis. And it is this factor that makes the R2 swan phenomenon, along with 3I Atlas, one of the most interesting open problems in modern astronomy around Earth. Several reports noted that R2 swan moved quite rapidly across the sky, but its sun-facing dust tail remained stable throughout the observations. It was not tangled, did not branch, and did not distort as strongly as a typical dust tail, which is clearly affected by the solar wind. That level of stability in a turbulent environment near the sun is clearly unusual. Astronomers Telegram, a reputable scientific resource, noted the phenomenon through two independent teams of observers, suggesting that the inverted tail structure was not due to instrumentation, atmospheric conditions, or local errors, but was a physical characteristic of the Comet R2 swan. Putting all the data together, a fairly consistent picture emerges. R2 swan is evolving in a way that makes it increasingly similar to 3I Atlas, almost like a parallel case of the retrograde comet phenomenon. Both have rare tails pointing toward the sun, both orbit near the ecliptic, both show signs of structural instability, and are currently located on nearly opposite sides of Earth. The simultaneous coincidence of so many factors makes the possibility of pure coincidence difficult to accept and suggests that both 3I Atlas and R2 swan may be participating in the same physical process that we do not yet fully understand. At this point, 3I Atlas and R2 swan are so similar that they could be considered phenomenologically twins. Dramatically, they could be likened to objects occupying strategic positions around the Earth. However, from a scientific perspective, the important thing is not to ascribe hostile motives to them, but to find the right model to explain the observations. One hypothesis that has been mentioned in recent years is plasma biology. The idea that under certain extreme conditions, plasma structures can exhibit complex organization, self-regulating behavior, and interactions reminiscent of primitive living systems. If this is considered an open research direction, comets are not simply ice and dust, but can contain complex, self-organized energy structures that respond strongly to the plasma and magnetic fields of the sunday. In that view, each time a comet passes close to the sun, it may be engaging in a larger interaction with the plasma environment, the solar wind, and the magnetosphere, rather than simply being passively evaporated. When two objects with similar anomalous properties appear at approximately the same time, occupying symmetrical positions around the Earth, this may be a hint at a physical mechanism not well described in current models. Along with the hypothesis of self-organizing plasma, more daring scenarios are not excluded. For example, the possibility of the existence of artificial structures or systems controlled by non-human intelligence. Although there is no direct evidence to confirm it, it is entirely reasonable to ask, because the universe is too vast and too old for humans to confidently claim that they are the only civilization. Astronomical surveys show that around us there are countless stars and planetary systems. Many red dwarfs near Earth have a stable, habitable zone for a very long time, which is a potential environment for life to develop. Further away are star clusters such as Pleiades, star systems such as Alpha Centauri, Proxima Centauri, Sirius. The number of exoplanets discovered is now very large, far exceeding the old concept of a universe sparse of planets. In that context, the hypothesis we are completely alone is increasingly difficult to defend in terms of probability. Earth is in the Goldilocks zone of the solar system, where conditions are favorable for liquid water and carbon-based biology. But that doesn't mean only Earth-like life exists. Theoretically, life, or highly organized systems, could emerge as plasmas, complex electromagnetic fields, or other energy structures. When we add the concept of multidimensionality, or extended state spaces to the model, The possibility of systems that can travel or interact between star systems is no longer entirely far-fetched. In this context, 3I, Atlas, and R, two Swan, with their rare reverse tails, peculiar orbits, and symmetrical positions around Earth, can be viewed as important case studies that force us to broaden our questions about space physics, life, and intelligence in the universe, rather than simply relegating them to the category of unusual comets and then ignoring